So if you remember, there are three sort of chunks of mass collaboration projects in the way that I think about it. There were human computation, open call, and then this last one is distributed data collection. So I think there's a couple settings where this can be really effective. People can be sometimes where researchers can't be. So I think the Malawi Journal Project is an interesting example of this, where, again, these people had access to a data collection opportunity that researchers wouldn't have had otherwise. By working with a distributed group of volunteers, you can have a scale that you can't have otherwise. eBird is a great example. So imagine ornithologists who want to know where every bird in the world is at all the time. Like that would be cool for ornithology, but they just can't do that scale on their own. But it turns out there are people that like to look at birds, and so that's a way that they can get that scale. And then the last thing I would say about distributed data collection is that sometimes it's hard to separate from human computation. So if you take a piece of text and label it as being like liberal or conservative, is that data collection or is that human computation? I would say that's kind of both. So none of these like buckets are completely separate from all the others, but this is one case I think people sometimes ask about what it is, and I would say it's kind of, but I would tend to put that more in human computation for the following reason. In that case, you're taking some input that already exists and you're doing some process on that, whereas like eBird or the Malawi Journal Project, you're actually getting a new observation of the world. So that would be how I distinguish between human computation and distributed data collection in those settings. One last thing. People always think, this is crazy, the data is going to be totally garbage. That is a very common reaction to any distributed data collection project. So what you should say, I think, is yes, if you're not careful, the data will be garbage, but we can have a bunch of checks to make sure that the data is not garbage. And the biggest thing that we can have is redundancy. So redundancy is a way of dealing with low quality information, not biased information, but noisy information, right? If you have tons and tons of observations and you average them together, that is a good way of dealing with low quality observations, as long as they're not biased. If they're biased, then averaging them together is not going to help. So it is not the case that you would ever want to do one of these things without having quality control things in place, and those things are totally, totally possible. And I will say, increasingly, we're going to see distributed data collection involving, I think, things like wearable sensors and other kinds of automated things, like eBird, Malawi Journal Project. Those were both requiring active participation, and I think increasingly we're going to see passive participation in these projects, which will allow them to scale much bigger. And so I think and also deals with some of the data quality issues, potentially. So I think that we're going to see a lot more distributed data collection in the future because of things like this and all the other things that are going to come after this. Okay, any questions about this? You look confused, Mike.
So that was my concern, right?
What?
That you'll get a lot of crazy data, right?
Yes.
And so quality control is possible, but it's a big fixed cost, right, to get right, and it's these kinds of projects are already risky. So how like, is there clear best practices that we can take off the shelf? And
no. I think it's a case-by-case basis, but let me give you an example. The Photo City project, I think, has one of the best mechanisms for quality control. So that's the one where they have to reconstruct the building by a bunch of people upload pictures of the building. So there, they have a few seed photos that they took as researchers, and then any photo that gets uploaded has to match onto one of those seed photos or one of the photos that matches onto the seed photo. So it's very difficult to upload a picture of the wrong building because it won't match. So I think as we move to more digital systems, we'll have the ability to do this automatic overlap detection this is speculation here. That is what I see more of in the future. Less of the eBird has like manual systems where they have volunteers review what comes in and so on. I think we're going to move more towards these automated systems. But I think one thing you said is really important to keep in mind about a lot of these things, which is high fixed costs. So this is a picture that I think should come up a lot. So this is the cost, and let's say this is the amount of data. Yes. So a lot of non-distributed data collection approaches, a lot of non-digital approaches, a lot of traditional approaches have a structure that looks like this: relatively low fixed cost, and then relatively high per unit cost. So if you're doing a lab experiment, you want to double your number of participants, you pay twice as much. If you're doing a survey, you want to double your number of participants, you pay twice as much. A lot of digital systems have this other property where they have high fixed cost and low per unit cost. So once you build all the software infrastructure to do PhotoCity, the per unit cost is basically zero. So things like this, if you're going to do something small, this is not a good to invest in all this fixed cost. But if you want to do something big, this is the only way it's possible. Right? So I don't think it's the case that you should do distributed data collection for everything. That would be crazy. But for certain things, there is no real alternative. Like, I think the eBird is a great example. There is no way those ornithologists could hire enough grad students to be everywhere in the world to count all those birds. Like, the only opportunity is for something like this. So I think we don't often think about what these problems are because this part of the space was off limits to us before, right? And so I think to the extent that we would imagine this is possible, then we might come up with ways that we could do stuff with that. Yeah? Maybe.